Hello, in this video I'm going to show you my progress on the brake test apparatus. I made some purchases on a new meter and did some design changes, so I'm going to show you those and do like a benchmark of 50 samples or so to see how it averages out with the same printout of the brake test. Those things are done, but let's have a look after the intro. So as you might have seen in the previous video, I've been working with this brake test apparatus that I designed. Previously I had like a meter here that didn't have option to store the peak load value. It was just a scale that showed the load, and I was having my phone to record a video of the screen while I was doing the brake tests. And as the screen was updating, it was very difficult to see at the exact moment when the brake happened what value was on the screen. It sometimes was a little bit blurry, so I was looking for a better alternative for the meter, and I found this meter. David Shorey was doing a short video clip on Twitter with his print in place, like print on fabric material test, and he had a meter like this, and I reached out to him and asked him what type of meter it was, and he sent me a link to Amazon, and I'll have a link to it in the video description. This is called a HF500 and can go up to 50 kilos or 500 newtons. the default value for it is newtons, and then you can select the unit like kilos and pounds. But this is a really nice meter. It has a digital connection to my computer, like a serial connection, so I can have an application running on my PC seeing the graph of the load, see how the load goes through. And this is like a push-pull device. You can both measure pulling force and pushing force. But the main thing here, I can press the peak button to store the value, and it also has a memory. So if I have, like now I have like 70 pieces of this brake test to do to run through like a baseline test, I can do one brake and then just hit save, and then it will save that value, and then go on to the next one. And when I'm done, I can do over 400 brakes or measurements in one go, and then I can play back the values one by one and enter that into my computer, so I can just focus on the brake process and then focus on the data collection afterwards. So it's really nice to have this memory, and it mounts with 4 bolts underneath the plate to the apparatus, so I don't have to create a mount like I had for the other meter that was custom made just to hold it down. Now I can just use 4 M3 screws that are here from the bottom up to the device, and it's really stable. And I also designed a new brake hook that goes into this hook on the device, and on the brake subjects. They go through like this, and then it pulls it over, and it's more stable than the thread I was having. I was having like a shoelace thread. It's the same one as I have here on the pulling arm, and it's much more stable setup. So that was the changes. So here with the close-up, I have the meter and the new puller arm, or what I'm gonna call it, and this is all the same mechanics as before. It slides and pulls on the subject. So I'm gonna showcase you how I load it up. I load in the test subject, and then I take this pin out, put this over, and pull the pin back in. And I can turn this on and set it to kilograms, and hit the peak value. And now if I turn the camera, you can see the value, and now I do the pull and release, and then the value is stored, and I can even rotate the screen. So now you see it better, and I pull more and relax, and you can see how this moves and pulls on. and as I go higher and higher, it goes to the point it breaks, and it stores the value, and I can hit save here to save this value. Then it will reset, and I can do the next one and carry on, and I'm going to go through all these models and play a time lapse of that process, and then I'm going to show you my results in the computer. So get ready for the time lapse. That was quite a number of tests, and I'm gonna enter the values into the computer and see how the results are. So now I have all the numbers from each measurement. It ended up being 74 measurements, and the range is from 8.23 kilograms up to 16.24. So it's quite a range, and I made some average numbers here and to see how much change in percentage. Maybe enlarge this a little bit, you can see it more. But so now with each average is at like a 10 samples, and this is the average this is the average number of kilos, and this is the change from the average. So this is the percent of change from the average number. So it's like 25% on average, the plus minus. But I will do some more math on this to take out maybe the extreme top ones and the extreme low ones and see how that goes, because some tests are like quite off than the normal ones. But this is the data, and I can use that to use as a reference when I do a test with a smaller sample, and that's the main idea, to do a filament review and maybe do 10 or 15 samples and use this reference collection of data to find out the acceptable average value. So if I have like a plus minus 20% result from this test, it has to be noted on the test when I do it for other materials. But this will be it for this video. It's a project video with my brake test apparatus. It's an ongoing project. Sometimes I get into the mood of playing around with this device and do some changes to it and do some brakes, like this 74 brakes. Took quite some time. But for now, I thank you for watching. I'm Martin, and this is 3D Printing Iceland. If you like what I'm doing here on the channel, please give it a subscribe and a like and a comment on the video if you want to. But for now, I thank you for watching, and I'll see you in the next one.